So here are the two pieces that we just talked about. For the book example, we defined a class novel. So this was done using the triple novel is of type RDFS class. And then we had a concrete instance of a novel, a concrete book. So this book here is of type novel. Yeah, and the new thing in there was using this RDFS vocabulary. Two more pieces of information that you typically see in knowledge graphs and that you should always provide is a label and a comment. In a few examples, you've already seen that the URI here is just using some kind of ID. Yeah, we had this last time with another knowledge graph, the Wikidata, and instead of something readable here, you would just have something like ID 1, 2, 3, 4, 5. So for the reasons that I explained back then, that you want to have an AI that can talk to a human and say, here, this is the title of the book, this is what this concept means. You want to have some natural language information. And there are two standardized ways for doing this, using the label and the comment. Label is just a short noun phrase, a short description of what it is. And the comment is a somewhat longer explanation, something like one paragraph. And remember, you can have language tags here, so you can have the same information represented in multiple languages. So first, let's look at the syntax. You can see it's in turtle format. So we have the subject here, the DBpedia entry for the book. And then for one subject, we have 1, 2, 3, 4 triples. So we don't have to repeat the subject 4 times. We just write it once. Then we have the label as the property, and we have it with an English language tag and a French language tag. And notice that in Turtle, you can just add more objects for the same property. So here we don't have to repeat label for the second one. Using the comma, we can show that these two are objects with the same property for the same subject. Then with a semicolon, we have the next property. So now the comment, which is a longer text, again in 2 languages, separated by comma. And then this part of the triple is finished. And then we can have further information about it. And at the end, a period. Let's look at the actual page for a second. So here is the DBpedia entry we just looked at. First, let's talk again about the URL, because that's a mistake many people had on the first worksheet. If you use resource, which is the canonical form of a DBpedia URI, and you put it into a browser, then DBpedia will redirect you to the page entry because it recognizes that this is a human using the browser, and it serves an HTML page. So this here is an HTML page. Now you can look at the source and you see it's just like any other HTML page. But if you do the same thing and do it from a program that understands RDF, it will give you back this here, the entry for data, which is an RDF page. And now you have an actual RDF file. Well, lots of triples here about this particular book. And the information we just looked at, the label and the comment here, you can see it in 3 languages. Different entries in DBpedia have different languages. Where they come from, we'll talk more about later. But here you have the information in English, in French, and in Korean. Both the 3 labels and the comments with the additional information. And then, of course, lots of other triples about this book here. So now you can also understand how assistants like the Google Assistant or Siri or Alexa work in multiple languages. It's not that they are translating the information. When they access their knowledge graph, they have the information in multiple languages available. And if you're using Google Assistant, for example, in French, then it will give you the information that is tagged with the French language tag. And in English, you get the version with the English language tag, and so on. Okay, for this, there is an exercise, but similar to before, we'll go to the next slide before I stop the video. So again, if you like, you can do the task now. Just pause me and come back. But in addition to looking at label and comment, we'll also define subclasses in the next exercise. So again, subclasses are something you know from object-oriented programming. You have a class like a student, and a student is a subclass of person. And then you have another class, professor, and professor is also a subclass of person. So how do you define the subclass relationship in RDFS? So you have two classes that you defined like we did before. And now you want to say that one class is a subclass of another class. And for this, you have the predicate RDFS subclass of. And then you define that C1 is a subclass of C2. So this also entails that all the instances of C1 are also instances of C2. If a student is a subclass of person, then all the instances of student are also instances of person. And you can have multiple subclasses, subclass of C3, and this is a transitive relationship between them. So now for these two things that we discussed, there are two exercises on the worksheet. So task 4 on exercise for RDFS label, and then task 5 for the subclass relationship. And then I'll see you again in the next lecture segment. Bye-bye.